Hello my dear students, today we are going to focus on the applications of aromatic, anti-aromatic concepts. You people all know very well about aromatic concept. What is aromatic? I'll tell you in simple way. So first one, the compound must be cyclic and it should be in planar structure and it should have conjugation. These three. After that, one of the important Haeckel rule, that is 4n plus 2 pi electrons. It should have 4n plus 2 pi electrons. Have you got it? So the compound, if it satisfies all these rules, then that compound is said to be aromatic compound. You all know very well about that. But whereas coming to the anti-aromatic compound, what is meant by anti-aromatic compound? So very simple dear here. That is, instead of 4n plus 2 pi electrons, just you take 4n pi electrons. Then that compound we can call it as like a anti-aromatic compound. So these are the basic rules you need to have in your mind while studying the aromatic compounds and anti-aromatic compounds. How can we distinguish? Means pi electrons. Remaining cyclic structure, planar structure, conjugation, everything is same. Okay. So aromatic means it should have 4n plus 2 pi electrons. Anti-aromatic means 4n pi electrons. Right. Now the concept which we have learned now briefly, we need to apply. So aromaticity or anti-aromaticity, where can we use? So with one example, we will have clarity here. By using this concept, we can decide acidic nature of the compounds. Okay. So here I am taking cyclopentadiene. I am taking cyclopentadiene. So if you take cyclopentadiene, whether it is more acidic or not, how can we decide? While when you compare with cycloheptadiene. So I want to compare these two. So whether which is more acidic we need to decide here, right? So now you see acidic nature means what? It has to lose one H plus. Okay. Now from here I am removing one H plus. Then you see dear, what is happening? So H plus is coming out. So now here what we are getting, due to loss of H plus, here getting negative charge and here hydrogen as it is, and here pi bonds. Okay, now you see this. Here you keep it corner. Now coming to the cycloheptadiene. So if you take cycloheptadiene, what is happening in the cycloheptadiene? Same manner, you remove one hydrogen here. Just we are checking. Right. H plus. Remove one H plus. Now here what is that product we are getting in this? So here we are getting product like this. Okay sir, we got it. Cycloheptadiene. Here you are talking about this, right? But in these two, which is more acidic we need to identify. And who will decide that acidic nature? So point is, here major point is, you see, if you take cycloheptadiene by loss of one H plus, it is converting like this. And now you check whether it is aromatic or anti-aromatic, right? So now here I am checking how many electrons are there here which are involving in the delocalization in the conjugated. See this, 2 pi electrons and 1 pair of electrons. Total 6 pi electrons are there. Total 6 pi electrons. 6 pi electrons means what dear? So Haeckel's rule. So it is a aromatic compound. It is a aromatic compound. Aromatic compound. Okay. So now whereas coming to the second one. What is the second one? Cycloheptadiene by loss of one H plus. What is happening here? Just you check it. Here how many delocalized electrons are there? See this. Here 2, 2, 2. Total 3 to 6 and 1 lone pair. So lone pair means negative charged electrons are there. That electrons also involving in the delocalization. So therefore, total how many delocalized electrons are there? 8 pi electrons which are in the conjugated system. Okay, so 8 pi electrons means it represents what? 4n pi rule. 6 electrons means what? It represents 4n plus 2 pi electrons. So, see, 4n plus 2 pi electrons, it is containing aromatic. So, it is containing 4n pi electrons, which are 8 electrons. So, now it is anti-aromatic. So, what's anti-aromatic? Aromatic. Okay, we got it. But which is more acidic? So you select, first one is A and you give that, second one is B. In the A and B, which is more acidic, tell me. If I ask you like that, you need to select here which is converting into aromatic compound that is more acidic. Which means if it is converting into aromatic compound, then we can say it is more stable. More stable means it is willing to give H+. Have you got it what I am talking? So whereas coming to the anti-aromatic compound. So anti-aromatic compound is less stable. So that's why it is not interested to give H+ quickly. So you can say confidently A is more acidic than B. Sir, okay sir, we got it. But the point is, how do we know which is more stable, which is not stable? You see this, here I have mentioned here stability of the what? Aromatic, non-aromatic, anti-aromatic. Anti-aromatic compounds are less stable, and whereas coming to the more stability point of view, aromatic more stable. Is it clear what I am talking? Now coming to the point, stability order you know very well, whereas reactivity order is opposite. Don't forget about this, right? So now coming to the nature of the compound. Here I have taken one more compound, you can see, which is given on the screen, right? So what is that? Once you check, that is cyclo. Nature of the compound also can be decided by using this aromatic and non-aromatic, anti-aromatic concept. So you see this here, nature of compound. So nature of compound, I have selected here one compound, cycloheptadinyl bromide. Cycloheptadinyl bromide I have taken. So now this cycloheptadinyl bromide, whether how it is functioning, I am saying it is functioning as like ionic compound. How can you say it is ionic compound? Generally covalent, I mean organic compounds are covalent compounds or polar covalent compounds mostly. So, but I am saying to you, it is ionic compound. But how can we say that it's ionic compound? Here also, that aromatic concept is involving. For example, here, if you take this compound is ready to give Br minus, okay, bromide ion. So now it is converting into what? Check it here. So here double bond, double bond, double bond. Br minus is going and it is forming a cation, and here now you have to understand one important point. What is that? Here Br minus, after coming out, this compound function as like an aromatic compound. So how sir? How means here no available lone pair in this carbon. Now whereas if you take in the ring 6 pi electrons are there. 6 pi electrons. 6 pi electrons means aromatic compound. So therefore it is ready to convert into this reactant, ready to convert into aromatic compound. Aromatic compound means it is ready to push that what Br minus come out, and it is functioning as like ionic compound. So the nature of compound also we can decide by using the concept of aromatic and anti-aromatic concept. Have you got it, dear? So more related topics we discuss in the coming days. Thanks for watching. Bye bye.